Book Impressions, The Art of Doing Science and Engineering by Richard Hamming, Part 2. This is the passage where he talks about AI. And it's very interesting to hear a seasoned computer scientist who, spent his career from the Manhattan Project all the way probably to the dawn of the personal computer, and hear his opinion and his views on neural networks and artificial intelligence from today's perspective. I think it's amazing. I mean, that alone is worth reading the book, just to see how people thought, people who are knowledgeable, people who really had something to say about computing, computer science, AI, and all these things. And what I want to talk about in this episode is, in particular, the question of what is AI and the struggle to define what is thinking, why are we using all these words. And I think Hemming is actually kind of leaning towards where we stand, and we're highly influenced by Richard Sutton on this front. That is, the definition of intelligence is the computational part of pursuing goals. So it's a procedural definition. It's not something. It's not like thinking, particularly now. I mean, there's people apparently who thought that intelligence is just something humans do, and everything else is not intelligence, which of course is totally wrong, because I mean, we are the result of intelligence. We came from something, and that something is intelligence. We call it nature, evolution, but that's intelligence. And the difference between us and other types of intelligence is simply that we can scale it up and speed it up for our time scale. Like, that's the difference, right? We have the ability to morph intelligence into our time scale, our size. And, for example, Kardashev 1, 2, and 3 societies are all defined as societies that can harness energy from stars, but they're always from the perspective of the human, because otherwise, I mean, we already live in a Kardashev 3 society, in a sense that we are, harnessing the energy of our galaxy, but of course, we are not doing it for our purposes. And this is the key of my argument in this episode, that it's really futile to compare intelligence with human intelligence, or to try to distinguish between machine intelligence and human intelligence. Or all of these things are futile, in my opinion, because they're not useful. What's useful is simply talk about the goals and the effect that intelligence has on the world. Now, where the human comes into play, and I think this is a very important point, the human is the discriminator as far as economic value is concerned. So that's where the human-machine interaction is not about humans using machines to do work, or none of that stuff. I think that really is the wrong way to think about it. The way we think about it is the human defines economic value, because that's where the most value will be generated. So machines, whether they are driven by human programs, whether they are self-programmed, whether they follow their own experience, whether they learn from their own experience, that's actually not so important. What's important is that the discriminator is going to be human as far as value is concerned. So, for example, it is futile to talk about the value of radiologists for medicine. Who cares? If I can get better results for less money, I will use it. That's it. That's what, that's how we function as a human race now. That is embedded in nature. I think getting more for less resources is something nature does also. It's not just us. We call it economics, but you can call it evolution. You can call it efficient evolution. That's up to you. The point is that if I have a choice A and a choice B, and I can get the same thing between A and B for less at A versus B, I'm going to go for A. Now, I might not do that in a single choice. Maybe I make a mistake. Maybe I'm irrational. But if I do it a lot of times, let's call it infinite times, then for sure A was always going to win. So this is a statistics game. This is a numbers game. And in that case, and that's what evolution is, everything that can happen under the laws of physics actually happens. And the more things happen, the more efficient they are. So in the long run, in the multiverse or universe, or however you want to look at the world, the better solutions will prevail. So having said that, I think that's how we see AI. I think that's very important. This is not just a philosophical conversation. This is not academic pedantry. This is real, because if you build systems now, for example, if you think about how to build the next generation of systems, if you think about Kardashev 1, if you think about how to harness the energy that's necessary for the intelligence that you think will be in demand, you want to build intelligence that is actually useful for humans. That's key, because humans will ask for the demand for intelligence from humans is infinite. That we said that is a Popperian argument. That is rooted in epistemology. This is not a belief. This is I don't know if it's a law, but you can easily translate this from Karl Popper's writings, where problems are solved. And every time we solve a new problem, a scientific problem or engineering problem, we create new problems, better problems, actually. And therefore, the more we know, the more we can even know more. So if we learn how to make lithium-ion batteries, then we also have to learn how to extract lithium. Once we understand how to extract lithium, we can learn how to dope lithium. And then once we learn how to dope lithium with cobalt, we can then learn how to get rid of cobalt and maybe replace it with something else. And the more batteries we have, the more storage opportunities we have, the more we can change the energy landscape. And then, for example, something like autobidder comes into play, that we actually need to find solutions that can change our electricity transmission networks and storage networks and all that. So the more we know, the more new problems we can create. And like I said in the beginning, almost by definition, we will have better problems to solve. And the more better problems we have to solve, the more we will, the more intelligence we will demand. So therefore, we think there is an infinite demand for intelligence, and that can be satisfied with something like a Kardashev 1 type energy resource strategy. Whether that is in space or not, I think that question is probably answered. In other words, it's more likely that we can get to Kardashev 1 in space than just on Earth. And that has a lot to do with legal NIMBY problems, not just physics problems. But anyway, I think to summarize this part of the conversation, I think, again, it's the human-robot interaction, the human-AI interaction is not about co-work. That's not what it's about, because robots will outwork humans. There should be no human on the battlefield, and there should be no human in the workplace. That is because machines will do the work, and I think that is almost inevitable. Now, there will be, of course, functions for humans. Humans have a function, and the function is to formulate the goals and discriminate against those goals. So that is the main function. That's why we believe the future of human labor is actually being entrepreneurs, being investors, allocating labor towards goals. That's what humans will be doing. That's where the most value creation will come from with humans. Now, of course, there will be legal, regulatory hurdles. I'm pretty sure the medical sector will try to resist as much as they can, the government sector. But nevertheless, I think over the long run, we will get to a point where human goals will be defined by humans and then executed by machines. And that is where human-machine interaction comes into play. And that's really the ultimate trajectory of AI.